Welcome. Today we are looking at Merkle swap from EraSwap Foundation. But before going into that, let's take a quick refresher about EraSwap network. As alternatives to Ethereum, there are a few other smart contract development platforms that propose their own separate blockchain that features for higher transaction throughput, but they compromise on decentralization for improving transaction speeds. Moreover, the ecosystem tools are most advancing in Ethereum than any other platform due to massive developer community. With EraSwap network, the team aims to achieve scalability, speed, low-cost transaction for entire EraSwap ecosystem, which particularly is currently not feasible in Ethereum mainnet. All these are done without compromising much on trustless asset security of EraSwap for community users. So with that, we are able to leverage the benefits of the Ethereum in EraSwap. So whatever you can do on Ethereum, you can do on EraSwap network. The EraSwap network uses Ethereum virtual machine, which is very well tested and valid. EraSwap network aims to solve the problems that are mentioned above faced by the ecosystem users by building a proof of stake consensus protocol based side blockchain on top of Ethereum blockchain using the Plasma framework. The network leverages the decentralization and security of Ethereum and the scalability achieved in the sidechain, which solves the distributed blockchain trilemma for EraSwap ecosystem. We all know currently Ethereum can do roughly 15 to 20 transactions per second, and all the smart contracts including EraSwap dApps that are deployed on Ethereum manage to work with it. While in EraSwap network, as per the EraSwap network testnet, there could be 500 transactions in every 5 seconds at 99% lower cost as compared with the blockchain Ethereum mainnet. This gives a huge room for transactions, over 10 million per day, which is advantageous for EraSwap ecosystem and its users. In the future, whenever the EraSwap ecosystem requires more capacity, it can be achieved using sharding. EraSwap network consists of bunches of blocks of EraSwap ecosystem transactions. A miner in the network produces blocks and a collection of these blocks are selected. Then a Merkle tree is created from that. The root of the Merkle tree is submitted to the network, which have the Plasma smart contract on Ethereum mainnet. This way, all the transactions happening on EraSwap network are fingerprinted to the Ethereum chain and vice versa. Talking about the user convenience, the existing EraSwap users have to pay gas in ethers on every dApps of EraSwap ecosystem. The launch of EraSwap network will enable users to move their EraSwap ERC20 tokens to EraSwap network proof of stake secure blockchain using a user-friendly Merkle swap portal, and they can do instant confirmation transactions and pay gas in EraSwap itself. They can also take tokens back to ERC20 to use their EraSwap tokens elsewhere on other dApps on Ethereum that welcome EraSwap tokens. But their users might have to pay gas in ethers and may wait long for transactions to be confirmed. There is a one DApp interface application which is under development, or the web interface Eraswap Live. Users come from this platform. Now on the extreme left, you can see layer 1, which is low bandwidth settlement high cost Ethereum, with the logo displayed here. On the top left, there is layer 2, high bandwidth settlement and low cost. All the time alley stakings are basically validated by nodes, and these nodes are finally mining the blocks. There is a randomness, like 5 random finalizers for every 40 blocks out of the entire group. Thereby, everybody will get a 99.9 equal chance to mine blocks. With every blocks, it have 500 transactions and 6.57 lakh blocks are being mined every month in the Eraswap network, with almost 67% consensus, and the hash rate is posted to Ethereum. So before anybody goes and posts up a bunch on Ethereum, the Kami or the bunch signers are going to get signature from everybody, and you get a message that they have got the signature. They keep on confirming the blocks forever. Inside a validator node, there is a block C and a Kami. A block C verifies new blocks and the transactions inside them. It also mines new blocks if it is a validator, and Kami guards the entire bridge between Ethereum network and Eraswap network. Technically, Kami is a background process that runs with Eraswap network node. This node checks the transactions up to an EVM context. While this is something more, a Kami looks after the proper functioning of the Eraswap network. It keeps a very closer look on the network for any kind of attack taking place. If it senses one, its guardian form gets activated and does everything it can do to prevent an attack from happening. Eraswap is imposing a strict validator node count limit to 100 nodes, starting with 3 foundation nodes. These nodes charge 1% as a node management fee of the reward received from the delegation. However, other nodes will have the flexibility to charge for node management as per their choice. Time alive 1 lifetime staking can be used by stakers to claim proof of stake seats for themselves or for others, which means it is possible for stakers to delegate their staking power to a responsible node. If more than one seat is being registered, the cost of proof of stake seats keeps increasing as per the time and situation. The responsibilities of the earlier discussed Kami includes post Merkle routes from Ethereum to Eraswap network, maintain proper consensus of Eraswap network. They also check for attacks and prevent them. And another one is to give remote control access to the owner of the node. This way, the owner is authenticated by the Kami using elliptic curve cryptography. Let's go back to Merkle swap. On the Merkle swap interface, we can see 3 buttons on the screen. It is saying ETH to ESN, ESN to ETH, and bunch submission. The first button you can use when you have an ERC20 token with you and want to convert it into the Eraswap network native token. And the second button here is used if you have the native token in your pocket and want to convert to ERC20. So for that we have Merkle swap, a plasma bridge made by Eraswap team. These transactions will be instantly confirmed on the network but to confirm on Ethereum mainnet, we have to do bunch submissions. And the details of the bunch have to be correct and it has to be approved by consensus so that the same transaction is posted on Ethereum. The first swap, which is from ERC20 to Eraswap network native token, is probably a very smooth one for even a new user. Let's check it out. To start with this, we have to connect our wallet. We can connect using Eraswap Live. You can load your wallet with this platform using your key store file or your mnemonic, private key or even MetaMask. Now we are connected through Web 3.0 to the blockchain. Here we can see ERC20 and native balances. The transferred amount or whatever transaction we are making, it will go to the Eraswap network first. So let's start with a transfer of Eraswap ERC20 to Eraswap native tokens. So our new balance of ERC20 tokens will be 0 and Eraswap native token will be 52. It will transfer our Eraswap to funds manager smart contract. We have to wait for the transaction to confirm. By the time we can try the swap between Eraswap native to ERC20. We'll open a new tab, open Merkle swap, we'll load the wallet, we'll connect to Eraswap Alpha mainnet. Here are the steps to connect to Eraswap Alpha mainnet. Select the custom RPC, enter the network name as Eraswap Alpha mainnet. Enter the RPC URL and enter the chain ID, then you can click save. So your new network of Eraswap Alpha mainnet is set. Shift to the Alpha mainnet, then you can see your Eraswap native balance over here. But a small thing is that the ERC20 balance is still 1. That's because the transaction or the swapping is not complete. Before that itself, we are trying the Eraswap native to ERC20 swap. Over here, we'll enter a value, say 5. That will make the Eraswap ERC20 balance 6. But finally, the amount will be 5 because the 1 will be deducted after successful swapping from Eraswap ERC20 to native. Now we are trying native to ERC20. So the final balance will be 5. Let's make this transaction. We'll make the transfer. Similar to earlier transaction, it will ask for the confirmation of the transaction. We'll confirm this. It is sent. We'll click OK. Now we'll wait for the transaction to confirm. It happened in a faster pace. The transaction is confirmed on Eraswap network. We'll wait for the bunch to be posted. Here we get some information about our transaction, in what block our transaction is included, and the latest bunch on Plasma smart contract on the Ethereum, which has block number of 9,94,379. So our transaction need to be posted through a bunch proposal. The immediate bunch with the highest bunch depth is 14. This bunch doesn't include our transaction since it includes only up to 10,10,763. Bunch with depth 15 will include or would include our transaction. But for that we need to wait 9,618 blocks to be sealed on IRASwap network. So if we need Ethereum urgently, then you can submit the multiple bunches with depths 14, 12, 11, 9, 6, 5. The ERC20 to native is confirmed by this time. We'll proceed to the next step where our block need to be posted. We'll proceed to the next step, which is to generate the Merkle proof. We can see what all Merkle proof is being generated. Then we can submit the proof to the IRASwap network. So we have to confirm our transaction, which is submitting this proof to the IRASwap network reverse plasma smart contract. Now we can see the success message which says our transaction is confirmed. Now if we check our balances, you can see clearly that our IRASwap ERC20 balance is 0 and our IRASwap native balance is 47. Since the 5 IRASwap from native to ERC20 has already been made in the other window. Let's go back and check our transfer from IRASwap native to ERC20. Here as we checked, our transaction is included in 10,17,511th block on IRASwap network. We'll note down this data. In the option called bunch submission, we can start the bunch submission process, and that will cost us depending on the fee pattern of Ethereum. It will ask for around 0.05 ETH. It is a maximum amount, but still we have to consider the GUI fees for Ether transactions at the moment. Here you can see bunch depth 1, 2, 3 and up to 14. For example, start block of the bunch depth 1 is around 9,94,380 and the end block is 9,94,381. Only one block inside that bunch posting. Similar to that, if we take bunch depth of 10, the start block is 9,94,380 and the end block is 9,95,403. So the difference between them will be 1023 blocks bunch will be posted. So we were advised to do the multiple bunch with depth 14, 12, 11, 9 and 7. Let's try one by one. In the bunch depth of 14, there will be around 16,383 blocks in a single bunch which will be posted. So let's try to submit the bunch depth 14. We'll select this and it will automatically check if the commies are active. The commies are active and it will request for bunch proposal. After that, the collection of signatures and verification of signatures will happen. The bunch proposal is prepared, and as I told you, it will start to collect signatures from each of the commies. The signatures are received and the signatures are verified. So now our bunch proposal is prepared for submitting. We'll select this. We can view our bunch proposal, which have the bunch depth of 14, transaction mega root, receipt mega root, last block hash, and signatures from all the commies. Now the final step of submitting the transaction, that is making the bunch proposal submit to the IRASwap network. We'll confirm the transaction, and now it is seen that it is sent to the Ethereum network. So here we can see that our balance is still not updated. That's because our transaction inside a block is not submitted as a bunch. So let's resume the previous action where we will paste our transaction hash, and let's see what all transaction bunches should be submitted. 12, 11 and 10. So if we need withdrawal on Ethereum urgently, as I told you, then we can submit the multiple bunches with depth 12, 11 and 10. Proceed 12. We are now submitting the bunch depth of 12. The same procedure of Kami getting the signature and verifying the signature is being done over here itself. We can see the bunch proposal, and after that submit the transaction. It is confirmed. Now let's do bunch depth 11, which have around 2000 transactions. We'll select this and the same process happens. Commies will be active. It will be searching for signatures. It acquires the signature, verifies it, and creates the bunch proposal. We can view the bunch proposal and submit the bunch proposal. We'll edit the gas fee 73 to 75. View on Etherscan. It will take some time to get our bunch submission approved. Now what left will be a single bunch. Let's check. The notification showed that my transaction is included in bunch depth 10. So let's move on to submit bunch depth of 10. The same process as earlier. The bunch proposal with the bunch depth and the signatures. While we were confirming the transactions, you might have noted one thing, that I edited the gas fees. That's because MetaMask wallet will automatically make you spend an average of 100 to 110 GUI per transaction. But as per ETH gas station, we only need to submit around a 72 GUI per transaction. That is a standard value. The standard speed of less than 5 minutes with which you will have to give 72 GUI per transaction. As we got the notification for our transaction to get confirmed, we need to submit bunches. We have done all the bunch submission and now we have been notified to generate the proof and submit the proof. Our transaction is included in block 10,17,511 on Eraswap network, and the latest bunch on Plasma smart contract on the Ethereum has last block number of 10,17,931. Our transaction is already included. Now we can proceed to submit the proof. This process will generate the proof for withdrawal from Eraswap native to ERC20 tokens. So now we have generated the proof of withdrawal. Let's see the proof that is to be submitted to Ethereum network. Yay! Our transaction is confirmed. We will have received tokens from the smart contract. But before that, let's check the latest Plasma bunch submission in eraswap.info, which is the block explorer from Eraswap Foundation. Here you can see the latest bunch submissions, which was done earlier. Now let's check the balance of our wallets with respect to Ethereum ERC20 token and native token. We have successfully swapped between native token and ERC20 tokens. Altogether, this platform enables any common man to access and interact with their tokens between the Eraswap native and ERC20 in the Ethereum blockchain. In reality, doing cross-blockchain transactions are highly complicated, but with simple UI and a wide variety of features, including transparency, makes the swapping process a far better experience. To find out more about IraSwap or other platforms from the IraSwap Foundation, check out our website iraswaptoken.io. Thanks for watching.